Welcome to the Ash Cloud. I'm Ash Sweeting. Today we are joined by Maik Kindermann, the inventor of the methane inhibitor 3-NOP, or Bovaer. Earlier this week it was announced that Bovaer has been approved for use by the FDA, adding the United States to the other 59 countries where it's available. Following a directive in 2008 by Fika Sibisma, the former chairman and CEO of DSM Firmenich, Maik began working on a product to inhibit enteric methane. 16 years later, Maik and his team have completed 119 trials and published 80 peer-reviewed papers, with another 31 papers in the pipeline. I recently caught up with Maik to hear about his journey developing Bovaer and how the conversation on enteric methane has changed over that time. Maik, thank you very much for joining me today.
Thank you for having me.
So firstly, congratulations on the approval by the FDA on Bovaer and for methane mitigation in cattle in the United States. You have spent the last decade or so working towards this, and that started at a time when methane, and especially enteric methane, didn't have anywhere near the prominence that it has in the global media landscape today. So can you tell us what led you to spend a decade of your life developing 3-NOP?
Yeah, happy to do so. To put this into the historic context, how we started, it was not me starting this. First, methane reduction in cattle has a long tradition in academia and industry. It's also not DSM asked this question before, so that 50, 60 years ago, people had already worked on this topic. And it was mainly because methane emission is associated with an energy loss for the cow. And people were thinking, if we can reduce the methane emission, maybe we see a performance gain. And methane as a climate gas was not the topic. In 2008, our chairman and CEO, former chairman and CEO, Fika Sibisma, he said, if we as a private company don't contribute to the most urgent problems of our time, we are not doing a good job, and we will not be in a good shape. And he identified two major topics. One is malnutrition, and the other one is climate change. And therefore, he launched an umbrella project, a huge project inside the company DSM. Now we are called DSM Firmenich, but 15 years ago, in the year 16 years ago, 2008, DSM. And this project was called Climate Change Induced Innovation. What do we as a private company see in our innovation activity to contribute for climate change mitigation actions? And there was a tiny little project in there where we said, can we find something to reduce enteric methane emission from ruminants, because methane is a strong greenhouse gas, and therefore we have a lot of cattle in the world, and if you go through the numbers, it's quite a sizable impact that all the cattle are producing for our climate. You are right, at this time that was pretty visionary, right? And so we started as a very small project, and it was also exactly the time when I joined DSM at the end of 2008, and we started to work on this project. And we had the discussion externally and internally, does it make sense? Because apparently nobody is really paying attention to methane. We kept on going, and after the climate agreement in Paris in 2015, things changed a lot, right? So if you place a bet, what will be the important things in the future? You have to also accept that in the moment you place the bet, you have not so many followers. But that's the thing why you're called visionary, because you anticipate already that at a certain stage that will change. And by the time it changed, you will be ready. And that's what we experienced in this project. We started early. We went through a lot, and we can discuss this along this discussion today, or our chat. We went through ups and downs, but we kept moving. And it appears to be we are ready when the time is there.
So that's 16 years ago, and against a lot of, I guess, a big bet at that time that what you were doing would one, get to the end of the project, and to have a market at the end of that. And I guess, firstly, that's great to see the vision from the chairman of DSM back in those days to actually invest in the longer term projects, which is something that seems to be less frequent in our societies today. And from your perspective, what was your role in the early days? What drew you into wanting to work on this project?
So I'm a chemist by training, and when I joined, I got this task. Hey, we have this small project. Why don't you take care of it? And it was not the most popular project because people said people have tried this in the past. The likelihood that something will come out of it is small, and therefore people were a bit hesitant to take up the project. Since I was new, it was easy to convince me, and also from my background, I'm very much interested in biological systems. It was easy for me to say I'm taking the risk, and the risk is anyway limited because I don't think that the project that doesn't deliver the desired outcome is very detrimental for your career and so on. Because if you don't try, you don't make progress, right? And you always have to give it another try. And that's also how progress is made, scientific progress. You always build on what people have tried before, and you carry it a bit further. I have no animal background when I started. Now I learned, of course, a lot about beef cattle and dairy cows. But when I started, I looked together with a small team. There were three of us into the literature. What has been done in the past, and what can we do? Turned out that in the year 2008 and beginning of 2009, what was available in the literature showed that there was nothing really convincing. So you had the usual suspect, and one of the usual suspects is feeding nitrate that has a long history, and then also some plant extracts and saponins and so on. But nothing will we say, this is it, right? And then I proposed, based on background, why don't we work on our own inhibitor? It's pretty naive, right? And at this stage, but sometimes being naive and having no idea what's ahead of you is also a key success factor, because then you move, right? And we heard this also during the conference at UC Davis. That's sometimes really important. Just start doing it. So we looked into who is producing methane, and strictly speaking, it's not the cow that's producing methane, but the microbes in the rumen of the cow, so the so-called microbiome. Diving deeper into it, you see who is responsible in this microbiome is the methanogens, the archaea. And luckily, the pathway in the archaea, how methane is produced, was already publicly available. So you have 7 steps that turn CO2 and hydrogen into methane, which is then burped out. And then from my perspective, I asked the question, where can we slow down the process along this way? Every biological transformation, also in our body, in every biological system, is controlled and driven by enzymes, right? By these molecular machines. They are passing substrates one to another and another. And if you want to interfere with such a process, you look into the structure of these proteins and ask yourself, can I find something that slows down the activity of a specific enzymatic step in this cascade that is producing methane? That's what we did. And then one of these enzymes was sticking out, which is the step 7, the last step of this methanogenesis pathway. It's an enzyme which is called methyl-CoM reductase. And the reason why this was particularly interesting for us when we started working on it, 2 things. The protein structure of this enzyme was already published in 1997 in the journal Science, so in a very high-ranked journal, by people from the Max Planck Institute in Germany. And when you want to design something and work very specifically on an enzyme, knowing the structure, knowing the active site, and how the transformation inside this enzyme is done can be very beneficial. That was one good starting point. The other one, equally important, is that this enzyme, methyl-CoM reductase, only appears in the methanogens and nowhere else in the cow and in the microbiome. So if we develop something specific for this enzyme to slow down methane production, our thinking was we can also exclude unwanted side effects. And that was the starting point. And then how do you do this? So we used very modern computational methods. We used structural biology to play first in silico on screen. How can we influence the activity of this pathway? And then we selected certain molecules, ingredients, and we went into a test tube testing. That was something that was luckily already available. So we tested in rumen fluid certain of our candidates. And that was a long process, right? That's many cycles, thousands of compounds until we found something that really inhibited in the test tube methane production. And then we knew that we were on the right path. Coming back to your question, how can it be that DSM is carrying such a project for so many years? One of the things is we were able to show an initial early success after 1.5 years. Yes, we are able in principle to find something. And that creates, of course, the support that you need for funding, for resources to carry on. And we kept on providing results, good results along the way, and always were able to generate more support.
So you said it took around 1.5 years to do that first stage that you...
For the first stage, yes.
And the molecule that you use, the 3-NOP, is that something that was already existing in nature, or is that something that you specifically developed to, or if it was existing in nature, where did you find it in nature, or did you have to actually develop that as a unique molecule?
So we developed it new. The compound class itself, these type of molecules exist in nature, but we had to search. But the molecule 3-NOP as such does not exist in nature. That's specifically developed as an inhibitor. But other compounds that look similar and also may have this effect or have this effect, they exist in nature. And but it's not so common.
So you got to, 2009, 2010, and you got the first initial results, and obviously some lab results are a long way from a product in the market. So what happened then?
So when we had the first results, and it was not only the active ingredient in Bovaer 3-NOP today, we have a bunch of them. What you do is a very systematic approach. First, you do an early toxicology assessment, because you don't want to have anything that's toxic. And also, when you look into methane inhibition, we always checked the volatile fatty acid production in our in vitro system, because if you interfere too much with fermentation, you also can reduce methane, but it's not really good for the fermentation process. So we also wanted to exclude this one. So we sorted out a lot of our candidates that showed initial methane inhibition, so that we say methane inhibition and a functional rumen, this needs to go together. And we had 3 candidates that qualified for this. And we tested all 3 of them in the first animal trial in sheep. And the reason why sheep, because they are small, you don't need much of the material. Normally, the activity of doing so is cheaper than the dairy cattle. And you want to know where do you land, because very often the translation from in vitro, from a test tube into the animal doesn't work, right? And then what's the point in wasting a lot of money? And when we had the sheep results, we were sitting together and saying, okay, looks good. Is it also working in dairy cows? So next trial is in dairy. Yes, it worked. Then we went into beef cattle, because the rumor was already spreading that we had something. So the first beef cattle trial was done in Lethbridge, Alberta, in Canada. Also worked. And then we knew we are really on a good path, and we decided we sit together and saying, how do we move this now forward into a bigger project and into a full development candidate?
So that in those early conversations, when emissions and methane was not as broadly talked about, what were obviously you have to find people, find researchers, find farmers to do all these trials with. What was the initial responses that you had when you spoke to those people? And then how did those responses and those conversations change over the years?
So the facilities of measuring enteric methane from ruminants, they were quite scarce around the world. So you had to find places and people that are working with you. And you had to knock on the doors And of course, these people, and just to name a few, it's Alex Histroff at Penn State, it's Karen Bushman in Lethbridge, Alberta, Canada, Chris Reynolds in the UK. They get a lot of these requests from people saying we have the magic bullet, and in 99% of the cases turned out it's not, right? So you had to do also a bit of convincing. But I have to say we were quite pleased that the academic world was very open to our proposal, because we also showed the in vitro data. We showed the molecular structure, we showed what we did, and that created a certain trust at the beginning. It's worth a try. And therefore, we had these three people early on saying, yes, we are willing to work with you and evaluate your technology. And this is also something, maybe it's a good moment to emphasize the openness that we have in sharing data, in sharing what we do, created very early on the willingness to work with us. And then, of course, when we had the first, second, third results, the rumor spreads, and at a certain stage, the situation turns around, and we get more requests for working with us than we can handle, right? So that's very normal. We also early on started to publish all our results, also the earliest results in sheep, in a peer-reviewed scientific journal, almost from day one of this project. Initially, people were a bit confused. Why are you doing this? Also in our company, that also has changed, because everybody recognized if you're doing this type of approach, you create a lot of transparency, a lot of trust. People can follow every step, no surprise along the way. That's one thing. The other one is you learn a lot by getting feedback. People are telling us, have you tested this one? What about that one? This is an important topic. For example, people were saying, have you tested the manure of the animals that get your Bovaer? What happens to the manure? That was not a discussion internally in DSM Firmenich. That came from the outside. And then people are saying, we tell you what you all need to test. And they did. They produced a paper publication. So win-win. We have this data, we can show it. And the academic community can demonstrate that they do their research and publish paper. And then also, it was around 2014, we had a pretty good idea on the computer how the Bovaer works, right? And then I said to the team, by the way, the story looks good, everybody's enthusiastic, but it would be good if we prove that it's true, that we are hitting this target and what. So we partnered again with people from the Max Planck Institute in Germany, Marburg, Professor Rolf Tauer, and his team, his former postdoc, Eva Duin, and we highlighted, we worked together on the mode of action. How does the molecule really works? And the good news is what we got out of this collaboration. The story was correct. We are only targeting methyl-CoA reductase. We tested it with a lot of other members of the rumen microbiome. They are all left untouched. We also discovered that the mode of action is even much more interesting than we thought. It's not only that the molecule binds, it has a specific way of stealing an electron out of the cofactor that is responsible for the methane production. And in this way, the enzyme gets temporarily deactivated. And then the molecule 3-NOP breaks down into two natural fragments that are present in the rumen anyway. And this is, since we demonstrated what's happening to the molecule, it also became clear that you don't find the molecule back in milk and meat or in the excreta, because it gets destroyed by its own mode of action. It's super stable, it does its job, but then when it steals this one electron, it breaks apart. That's one thing. We also discovered that the molecule is more effective than predicted from the computer model. That's normally not happening. So Professor Eva Duin in Auburn University said, we need to find out how and why. So what happens is one of the fragments that we are producing can undergo the stealing of an electron once more. So the molecule acts twice. And therefore, we had a clear scientific rationale, how it works, why it works. And we published this in PNAS, in the Proceedings of the National Academy of Science in the US, pretty high-ranked journal. You can also say in this way we helped competition in moving in the same direction, but that's almost a good sign. And secondly, the regulators, when they also saw this publication, peer-reviewed scientific publication on mode of action, here we are pretty unique with this development of Bovaer. And again, it creates a lot of trust that nothing unwanted is happening. And therefore our strategy also on the long run paid off, because at the beginning people were not everybody was happy that we are publishing everything. That has totally changed. Now I'm getting phone calls also from our top management. When do we get the next publication out? And to finalize this topic, as of today, we have 80 scientific peer-reviewed publication out and 31 in the pipeline. So our expectation is later this year or early next year, we will surpass 100 publications. And we continue doing so. Everything we do gets published. So we make the data available for the public, for academics, for policymakers, for journalists, for everyone.
So that was 10 years ago that you found out the mode of action. You had the pleasant surprise, a wonderful surprise that it actually worked more effectively. That's, you've got to love that. But that's 10 years between then and now. So I guess from what you're saying, I can gather the very small team of 3 that you started off with had somewhat grown substantially. I imagine the profile within DSM internally had also changed. Do you want to talk us through the evolution on that side?
Yeah. So when we had the early success, you're right, 2 things grew: the project budget, right? Because animal trials, everybody around the world will agree that's a pretty expensive exercise. And then also handling all the things. So our team grew from all aspects. One is on the animal nutrition side, people taking care of, how do we set up trials? What's the trial protocol? How do we do this? Then on the analytics side, we need to work on the inclusion level of the molecule. Is everything correct? Do we find it back in the feed, right? And how much, and so on. So our analytic department grew. We have more and more contracts with the outside world. So we also get a dedicated person from our legal team working with us on the contract, so that is handled. We also started to think through what is required for a regulatory dossier, for a registration dossier in the different regions, right? So we have a lot of experience internationally, our company DSM Firmenich, and therefore we had early on regulatory support. And then we saw the following for registration dossier: the efficacy trials, the tolerance trials that you need, and toxicology trials. It's a pretty extensive list of things that you need to do. We didn't start this all at once, but we start with the early steps on the toxicology side. We also worked on what's the best form to feed for the animal, right? And so we have a dedicated team on feed formulation and on formulation of active ingredients in itself. We made quick progress. What's the optimal dose per animal and per day? But that's also something you need to discuss, because the very first trial, how much do you feed? It's kind of not obvious, right? So we had a long discussion. What's the best dose? So here we have a pretty good idea. One thing that might be a bit overdone is the amount of trials that we have now in our books. Is this really necessary? The early days, we had to convince 2 sides of the story. One is the external world that it works. And everybody said, my cows are different. My feeding system is different. My diet is different. Will it work, from a feedlot diet? Will it work in backgrounding diet? What about grazing animals, then TMR animals? The TMR is different in different regions of the world. That's one aspect where we also had to convince ourselves that this is really getting real and big, and therefore we were running quite a lot of trials at the beginning until everybody internally and externally was convinced that it is. We also wanted to be sure that we don't see any unwanted side effects, right? No impact on performance parameters, and that requires quite a bit of trials. And at the beginning, trials had...
Yes. You know how many trials you have?
Yes.
The papers are up to almost 80 published and 30 odd in the pipeline, but How many trials have you run over the last 16 years?
At the moment, we have finished 119, and a lot currently running. So that this is also growing, right? And now we also have more and more commercial trials and pilot activities, and the number of animals are getting bigger. So it's quite a sizable number, and on every continent. That's also important. It's Europe, it's North America, it's South America, and it's Oceania, Australia, and New Zealand. So we are working also with all the relevant academic, agricultural institutions and commercial partners.
So what's the size of the Bovaer team today that it's grown from back in the first days?
Oh, it goes towards 100. It's difficult because we are working in this big organization, also in the Matrix organization. So yeah, but it's pretty sizable. And you also saw the news that we are building our dedicated plant for Bovaer in Dara in Scotland. And there we are also staffing up the number of people. And the next phase is now starting. And we are getting ready for production in 2025. So the team there is also growing quite substantially.
And then back to 2014, you knew the product worked, you tested it, you were happy with the results. What comes next after that? What's the next step of that journey?
So two things have happened. One is preparing slowly but surely for the registration dossier, right? And that starts with toxicology work. And I can tell you, we have over 100 toxicology studies finished, which is on animal safety, on human safety, and on environmental safety. And that starts with some small studies that are required and goes up the ladder until the most expensive studies, which are animal tolerance studies, right? Where you feed it to the animal and you test the limits and what can happen. And then the next thing is, how do you make enough material? I can tell you the initial trials that we were running, every single gram was made in my lab, right? It was my team. And every single gram was debated. How much do we give away? Can we afford, right? And so on. So we also needed to make sure that with the growing success of this project that we have enough material. So what our team at DSM is pretty good at is developing processes in terms of manufacturing process. So we have dedicated teams, and they are really doing a fantastic job in looking how do you industrialize such kind of activity. So we also started early on, how do we get the first kilogram? How do we get the first 1,000 kilograms, a ton, right? And now this is all up and running, but this also started early on. We don't want to have a successful product and no clue how to make it. So that all goes hand in hand and a bit in parallel. The question, when do you start this activity, is a bit dependent on individual preferences, always a team discussion, right? But it was pretty much working hand in hand on these topics.
And with regards to the regulatory process, every country or region has its own different set of guidelines, rules, hurdles, etc. So obviously you've just had the FDA give their results, but it's already in the market in other parts of the world. And what's the challenges, or how is it navigating all those different regulatory environments and managing to get it into the ones that may be more accepted or more easier to get into, and then obviously places like the US, which are very big. It's a big market, and also have that global credibility. If it's past FDA, then other people also recognize that.
So what we did not do, and I like to emphasize this, we didn't go for the first market where is almost no regulation, right? Because that's also in our work ethics. If we bring such a global product, we want to have the hard hurdle first. So we went through Europe, EU registration, which is a pretty extensive package that you have to deliver. And saying, if we get this over the line, it will send the signal to other markets. But then we also have most of the data already ready. Because if you prepare a registration dossier, the data requirement is pretty tough. And just to give you an idea, if you print the EU registration dossier, it will be 100,000 pages. Nobody prints this anymore, right? But it gives you just an idea that the data collection that you need to do for these kind of products in registration is pretty extensive. That's also something that I'm trying to explain also to certain startups, because very often I have the feeling people think we have a molecule, we feed it to 10 cows or 12 cows, and then we have a product. That's not the case, right? And from there, when we prepared the EU registration dossier, we started also to file in parallel in other jurisdictions. For example, in Latin America, Brazil, and Chile, we filed, but we had the data package, and many countries are saying if it's registered in a major market, and the major market are usually the EU or North America, we accept a lot of this data and you don't need to run extra trials, right? So we filed there. We got a bit of a positive surprise because instead of Europe being the first market approval, it was Brazil and Chile. So that hit us as a positive surprise, but we're not complaining, but Europe followed right after. And at the moment we are, since before yesterday when the US came on, we are in 59 countries, and the list, so the list is pretty long. We want to make this a global product. And so we also have on our list China, India, Korea, Japan, right? And different countries have different rules for registration. And therefore we have a very professional and big regulatory team taking care of the different dossier filing and making sure that we fulfill the requirements of the respective country. Some countries are saying you need to do extra trials here in our region. Some, they say, if it's registered in the EU, we are happy to take this on board and no extra work done. But that's something we are looking into on an individual basis, country by country.
So on that note, are there any particular nuances of that regulatory process was there any, you mentioned earlier that everyone asks whether it works in a similar way in their environment, in their feed system. Were there any great differences in efficacy or the way it worked across the different trials that you run?
So what we learned now, since I'm describing it, it's pretty obvious, but that's also a learning process. I mentioned at the beginning of our chat that strictly speaking, it's not the cow that's producing methane, it's the microbiome. Now, the microbiome, the activity of the methanogens and the number of the methanogens is entirely driven by the diet, right? And therefore, we were wondering sometimes with the same dose, but in different regions, different feeding systems, we had different methane results. Now we have the largest data collection when it comes to Bovaer for methane inhibition, and we also have a pretty good idea on all the dietary composition. So we were sitting down also with an international consortium of researchers, also our own team, and we are saying, how can we explain this? And what's required, that not everybody needs to measure methane in his garden and his production system, that we have an overarching predictive formula how to connect a specific dose of Bovaer and a different dietary composition feeding system. So we went through all the data and we found the methane reduction is dependent on the dosage of Bovaer, on the NDF content of the diet, and the fat content of the diet. We put this into a predictive formula and published it in 2022, for example, together with the people from Wageningen and from UC Davis. And that's now available for everyone. And if a farmer, a producer has an idea about the diet, then you can say with this specific, and that's for dairy, for this specific diet, we get with this dosage of Bovaer, this methane reduction, which is particularly important if you think about carbon accounting tools in national inventory, because since this is now widely accepted, it goes into these carbon accounting tools, the Greenlopwijzer in the Netherlands, Cap de Air, or the Cool Farm tool from the industry. And there's a number of tools available, and they all accept this predicting algorithm. And therefore, now when we start a trial since 2 years, before we even start a trial, we predict what's the outcome. And I can tell you we are spot on now. So this uncertainty is gone, which makes regulators and also the industry pretty happy, because it's consistently delivering what you predict, and therefore everybody can work with it.
That's wonderful, and that's specific for dairy, or that works across beef and dairy as well?
It's specific. The published version from us, it's specific for dairy. Other people have already worked on the meta-analysis for beef, but we are running also, and we will publish soon our own meta-analysis for beef. But it's kind of the same story. The algorithm looks a little bit different because beef have a different microbiome, different feeding system. So therefore we also don't put everything in the same basket. We say the feedlot diet is so substantially different from what you see in the backgrounding. It's a bit misleading if you put this all into one bucket, right? And we are currently actively working on it, and that will be published soon. And then this box is also ticked.
So the methane conversation, especially since COP, I think it was 26 in Glasgow and the Global Methane Pledge, has changed a lot in that time. And for someone who's, been on this journey for so long and, been in the position you're in for so long, how have you perceived that change in the global conversation around methane over those years?
Yeah, it's great that you're touching this point, because methane was a long time not ignored, but there was not really high on the radar screen. Everybody was talking about CO2, right? When we talk about cars and when we talk about climate change before a COP, it was all about CO2. There is a specific aspect of methane which I like to emphasize here. Methane is a very strong greenhouse gas. Depending on the time frame you're looking at, it's between 30 and 80 times more potent than CO2. Methane, on the other hand, gets faster destroyed by natural processes in the atmosphere. If you take these two things together, a strong greenhouse gas, faster destroyed in the atmosphere, means whatever we do on methane is the fastest way that we have to reduce climate change and global warming. So if we reduce methane today, it will have a much faster impact than CO2, because the lifetime of CO2 in the atmosphere is 100 years or 100 years plus. So even if we reduce a lot today, the time lag until we see the measurable effect will be longer. Methane is different. And therefore, that's also kind of a message to the agricultural sector. If you move on methane, you can get out of the corner and saying we are contributing much more than you think to climate change and global warming, and you can use this scientific data to your advantage in the agricultural sector. And what we are seeing is, although it's a complicated topic, more and more people are getting it, and therefore we see an increased interest in reducing methane from the agricultural sector, also from other sectors. But that's a unique opportunity to slow down climate change and global warming, and a unique opportunity on the communication aspects towards the public.
It's taken, so there's a lot of countries or jurisdictions, be that states like here in California, that have made pledges to reduce methane emissions by 2030. In fact, the Global Methane Pledge is well over that's 150, 160 odd countries.
Yeah.
But it's taken you 16 years to get to the stage from the drawing board into, or from the commitment from your CEO to the market. And obviously, once you've done things, someone's done it once, doing it a second time is potentially faster than the first time.
Yes.
I guess, what thoughts, changes, opportunities are there to, accelerate the process of, getting other options available to help reduce methane from livestock, from a regulatory or a social perspective or a funding perspective, or in the big picture?
So when we see what the Global Methane is doing, Methane Hub is doing, right? They are already collecting a large amount of also philanthropic money to fund respective activities. For example, not only for cattle, but also in rice paddies, right? Rice fields, all these opportunities that you have to reduce methane emission, right? So that's something we see. We are collaborating a lot with the external world, and we offer a lot of our expertise, what have we learned, to the outside world on the registration process. And we also see that certain jurisdictions are getting the idea that moving faster on the regulatory process could be beneficial. One example was Canada, right? They accelerated this. How do you regulate a feed additive or feed ingredient that reduce methane? This is also a bit changing. The EU was again visionary in creating a category in their regulatory framework that they said you can register things that are good for the environment. That's where we registered Bovaer, and that's now also spilling into all other countries saying, oh, that's a viable way forward. So we see that regulators are also willing to accelerate the approval process, provided no shortcut, provided you hand in the right data. So that's really a positive thing that we are seeing.
I imagine you're speaking to many farmers over the years. And what are they saying at the moment about what questions are they asking? What's their levels of enthusiasm about the registration of Bovaer that's just come through?
Yeah, if you look into the entire value chain, right, where you take it from the producer of such a feed ingredient, feed additive, to the feed millers, the farmer, and then it goes, depending where you move, retailers, the supermarket, the dairy processors, supermarket, and then to us, the consumers. What we need to do is taking away the concern, or the burden from the farmer, that the perception is it's just an additional cost that's hitting my desk, period. And therefore, we're putting a lot of thinking into what's the appropriate business model and the right incentive structure so that it's cost neutral on the farm side, and who has an interest in paying, and how do you set this up? You mentioned methane pledge, or the sustainability pledge, reduced greenhouse gas emissions. And of course, the big dairy companies around the world have their pledge in their annual report or on their website. And for them, the implementation of Bovaer is pretty easy, pretty fast. And therefore, the discussion is not necessarily only with the farmer, but more downstream in the value chain, who has an interest and who has the means to finance the activity. And then how do you set up the incentive structure? So what we see is you have a lot of these evaluation systems for farm sustainability and points. Turns out that the next step is getting methane emission into these incentive schemes. How do you measure this? How do you track and trace this so that you avoid fraud, right? We are getting there. But then also saying, how do you monetize this? What are the flows? How do you allocate, for example, a methane emission reduction? Is it going all to the milk? Because you cannot allocate it several times. You cannot allocate it to the milk, then the same amount again to the meat, and then the same amount to the hides for the leather industry. So you have to find a way what gets allocated where, who pays for the invention, who can claim the most benefits. That's a complicated discussion. And that's also where we need to get our heads around what we do, right, together with the industry, and saying, how do we make this a reality? And that was also something not necessarily, when you look at me on my radar screen, that's something that we discovered once we were ready for the market and having the discussion. Okay, there is a next step to do. How do you set up the incentive structures?
So that's a long way from looking at the academic papers on emissions and the enzymes that work in the methanogens to block that final process. So, how has that journey been from your perspective in terms of, that growth, that development, or the expansion of where you're working?
I mean, one of the consequences, the positive consequences, if you go through all these steps and discussions, and also into the business development side, and how do you monetize this, there is a lot of learnings that we can feed back into other product developments here in the company, specifically when it comes to emission reduction and sustainability. So this is really a win-win, where we funnel back our learnings from this Bovaer activity into other areas of the company, specifically in our business unit, animal nutrition and health, right? How do you do this now for other products? What are the watch outs? How how can we make progress there. So that's an immediate benefit. But in order to get there, you need to go through the hard learnings at the beginning. But that's, of course, something that our company did. So we pulled it through with all the consequences. And now we are at the right moment in earning the learnings and also the credits there.
So I guess you've covered a lot of this already, but now that it's registered in the US and 50 odd other countries, it's not like you're about to put your feet up and find a nice shady tree and sit down and have a rest. So what's next?
I mean, now we have done the first step. We are in a critical phase of ramping this up and making this a success, right? If you stop now, that's not a wise thing to do. So I'm traveling a lot, talking to people, explaining, also on questions that you raised in this chat. There are a lot of questions around that we answer. And it's always beneficial if you talk directly to people, meet them back, because nobody is reading 80 publications. And what's the point? You need to be able to talk to someone asking the question. On the carbon credit side, or the insetting, the carbon insetting, and also the incentive structure, we are working a lot with the industry together, beef as well as dairy. How do you make this a reality? What are the learnings from our side that we can share with these companies? What systems do we have in place, right, from our Bovaer side? And that's a huge effort. And at the same time, we are building the plant. We will celebrate the highest point of the building in 2 weeks. And then this gets operational. And then we have the output to serve, a global product. But there's a lot of hand-holding required at the beginning. But we also see that the political sector, or the public sector regulators, are moving, right? And therefore, we need to be ready to support the product into the market at this stage.
Thank you very much. Before we go, is there anything that we haven't discussed that you'd like to add?
No, I think we touched most of the point. I'm happy again to share the story. One thing for us, very important, when I travel and I have so many discussions, I still feel this collaborative, open and transparent way of working that we brought into the world with Bovaer, into this, it's still more unique than I wish it would be, right? Because we still see a lot of, this is my garden, I'm not telling you what I'm doing. And then the perception, we are a big company, right? DSM Firmenich, 30,000 people, 12 billion turnover last year. The perception is the big industry is the bad guy, but it's not, right? We are very collaborative. We are sharing all our data. We are providing as much support as we can for people that want to work in this field of reducing enteric methane. Because as you said, we went into this 16 years. So we accumulated with our team quite a bit of learnings, but we're very willing to share all our learnings for the benefit of the planet. And I find this protective attitude that we see sometimes, it's just, you don't make progress in the 21st century anymore if that's your attitude. That's a bit of a surprise, but we won't change. We continue in working collaboratively together with the academic world as well as the industry and the public sector.
Maik, thank you very much for joining me today. It's been a pleasure.
Thanks a lot for having me.
You've been listening to The Ash Cloud with me, Ash Sweeting, in conversation with Maik Kindermann, recorded in California in May 2024.